this video is going to wrap up that last page of the notes, and I'm also going to go through a homework problem with you. So this is a table of different values of f, g, f prime, and g prime, and this is going to be a good review for us for all of our derivative rules that we talked about so far. So we are going to look at part A. Asks us for 2 f of x at x equals 2. So we want the derivative of 2f of x. So that is going to be derivative of 2 times a function will just be 2 times its derivative. So 2f prime of x. And so I just want 2f prime of 2, which equals 2 times f prime of 2 is going to be 1/3. So that's 2/3. Done. Then I want f of x plus g of x at x equals 3. Well, the derivative at 3, derivative of f of x plus g of x is f prime of x plus g prime of x. And so I want f prime of 3 plus g prime of 3. That's going to be f prime of 3 is 2 pi plus g prime of 3 is 5. Now, f of x times g of x is a product rule. So we're going to go through the product rule. It's going to be first times derivative of the second. Derivative of g is going to be g prime at 3 plus second times derivative of the first. Derivative of f is f prime. So now I want to plug these in. And I would get 3 times 5 is 15 minus 8 pi as my answer. Next up, it's going to be a quotient rule. So it's going to be low d high, derivative of f is going to be f prime, minus high d low over the square of what's below. So take g of 2 and then square it. Here we go. We're going to plug in our numbers. So when I get a common denominator here of 3, this is going to be 20/3 over 4, which is 20 over 12. Those are both divisible by 4, so we can make that 5 over 3. Next one, here's where we get to the chain rule. Because our derivative here is f of g of x, so we want the derivative, we want outside derivative of the inside function times derivative of the inside part, g prime of 2. So let's figure out what that is. We want f prime of g of 2, so that's f prime of, g of 2 is going to be 2 times derivative of the inside part. So g of 2 is 2. That's why there's a 2 there. So that's going to be f prime of 2 is going to be 1/3. And then g prime of 2 is -3. So those are going to cancel, and it's just going to be -1. Next up, I want square root of f of x at x equals 2. Well, that means derivative of square root, that's going to be 1/2 times f of x -1/2, which is 1 over 2 square root of f of x. But then that means I have another function inside of that square root, so I need to use the chain rule times derivative of the inside part. Derivative of f of x is f prime of x. So we'll go at 2 for each of those spots. So this is going to equal 1 over 2 times the square root of f of 2, which is 8, times derivative of the inside part. F prime of 2 is going to be 1/3. So that equals, we've just got the 1 on the top. We have 2 times 3 is 6 times square root of 8 is going to be 2 root 2. So that will be 6 times 2 is going to be 12 root 2. If you want to get the square root out of the bottom, then you could say that this is square root of 2 over 24. However you prefer that written. Again, I suggest you try these on your own. Pause and try them and see how you do. And check these as you go along. Next one is 1 over g square root of x. That's the same as g of x to the negative second. And so derivative of g to the negative second, that's going to be negative 2 times g to the negative third. And then times derivative of the inside part. So if I'm going to do that, we'll get to the 2's over here later. If I'm going to do that, that's going to be negative 2 over g of 3 is negative 4 cubed. Then we have times g prime of x. G prime of 3 is going to be 5. So that's going to equal negative 10 over negative 64, which is positive 5 over 32. And the last one of these, I have the square root of f squared of x plus g squared of x. That is going to be a chain rule in a chain rule. So you need, first you need to deal with the square root. 1 over 2 times the square root. Times derivative of the inside part. That means we need to deal with f squared of x plus g squared of x. So derivative of f squared of x is 2 times f of x times derivative of the inside part. Same for g squared of x. 2g times g of x times derivative of the inside part. So I'm going to simplify and move around a little bit. These 2's can cancel with this 2. And we want to plug in 2 each time for each of those. And now it's just a matter of plugging in numbers and doing some simplifying. 8 times 1/3 plus 2 times negative 3 over f squared of 2, so 8 squared plus g squared of 2, 2 squared. So 8/3 minus 6 over the square root of 68. And we're just doing some simplifying of the square root here. If you get down to the final simplifying, that's going to be negative 5 square root of 17 over 51. That would be simplifying so the square root's not on the bottom anymore. Last one we'll do here is actually off of the homework. And we're going to talk about this a lot more in a future chapter, but it also does use the chain rule. And so if we're asked for ds dt here, well, there's no t. So what we're essentially going to do is we're going to create a t variable, and we're going to cancel it. Basically what this is going to do is it's going to give us a way to express how you might have a side length s and an angle theta, and you're wondering how they change over time. Derivative might be able to answer a question like that. And so we're going to use the chain rule to do this. It's just written in a little bit of a different notation. The ds dt would equal ds d theta, which is the derivative that we're finding, that we can actually find on this side, times d theta dt, times how theta is changing over time. And what this lets us do, this is just algebra, that these d thetas would cancel, and we wind up with ds on top and dt on the bottom. And so all that means is that ds dt is going to go on the left, equals, and then ds d theta is the derivative of cosine of theta. Derivative of cosine of theta is negative sine of theta. That's ds dt. And then we just write times d theta dt. Right, that's all we're doing. It is a chain rule of sorts where we're trying to manipulate functions happening within other functions. So it gives us theta is 3 pi over 2, and d theta dt is 5. So ds dt is going to equal negative sine of, well, theta we said was 3 pi over 2. And then we said d theta dt was 5. So negative sine of 3 pi over 2, that's going to be negative 1, and then times 5. So negative negative 1 is positive 1 times 5 is positive 5. And there's your answer. So similar thing for the problems that are next to it on that homework assignment. And that's all for those notes. The chain rule involves a lot of different ideas, and we're going to keep using the chain rule going forward. So this is going to be an important type of derivative to know how to take. So thanks for watching. Talk to you more soon.